welcome to my lunch and learning session today. So for today, we are going to talk about the fundamental of pressure relief devices. So this is our brand AST that we carry here in Turcomp, but today we won't be talking about AST. So we'll be talking more on the technical side and the fundamentals of relief device. Alright, so let's start. So what is the main function of a relief device? So as you can see, the header above is mainly for overpressure protection. So in daily operation of your equipment in your plant, the maximum allowable working pressure could increase beyond the safe levels. So meaning to say there is a certain set pressure, maximum allowable, it will be more at certain time. So some of the incidents that can cause the overpressure would be operator error, blockage at some of the discharge pipe, where you have a pressure accumulation, you will have fire exposure, utility failure. All of this is some of the incidents that can cause overpressure incidents in your plant. So normally in plant you will have practically three potential lines of defense. So the first one is inherent safe design, passive control, and active control. Since the inherent safe design can't eliminate all the hazard, and since the passive design is exceedingly expensive, means you need to upgrade your equipment to very expensive equipments. So one of the ways that you can look at is to actually use a pressure relief device. So these are the common solution that we use in many plants. So let's just move on. So how do you know where do you place your pressure relief valve? So in process system plant, you will have a process engineer that will perform each evaluation of any areas that have a potential overpressure scenario. So the plant layout, what they will do is they will actually review the process condition, the plant layout, and they will do some analysis. So the results of analysis are one of the basic elements which is necessary for the selection and also the sizing of a pressure relief device. So normally what the standards that will be used is actually API 520, 521, for example ISO 23251. These are the specific requirements on the guideline for examination principle cause of overpressure in your plant. So there is also a guideline over here besides the API 520, and later on we will see later on that will be more applicable to the design of the pressure relief valve. So moving on, these are some you could say standard codes that we use in designing of a pressure relief valve. As you can see, ASME 7 over there, that is for boiler and the pressure vessel code. B16.34 is normally used in the standard flange or threaded welding ends of valves. So in PSV, PRV, we will use the same flange because it's very common. API 520, as I said earlier, that is for sizing, selection, and installation of a pressure relief device. That's what I said. 521 is for guide for pressure relieving system, and you will also have all of this, which is a different standard using different continents. Like for us here, we are more into oil and gas industry, so we will be looking more into API. So these are some of the relevant standards that our manufacturer can make accordingly. So let's move on. Okay, so the pressure relief device. So PSV or PRV are basically equipment that are designed to open during an emergency or abnormal condition to prevent a rise of internal fluid in excess of a specified design value. This is actually your set pressure. So there are two main categories of a relief device. So number one, you have a reclosing type. Reclosing type are devices that are designed to open and close after normal condition have been restored to prevent any further flow of fluid, meaning to say it will open and it will close. And the second type is a non-reclosing type. So these are these devices that will remain open after certain operation. So if your set pressure is higher than if your operating pressure is higher than your set, it will burst and it will remain open. So these are non-reclosing type, means it's only for one-time use. So moving on, so when do you actually know where do you use a non-reclosing type or a reclosing type of a safety device? So the selection of a type safety device depends on several factors. As you can see, for non-reclosing safety device, we will use it when you have a very low capital or maintenance saving, meaning to say you will have daily maintenance, service, and so on. You can use if you have many maintenance coming on from time to time. So you can use this non-reclosing type. Non-reclosing safety device also is commonly used when you have a very rapid pressure rise situation, like a runaway reaction. See, when you have a runaway reaction, a PRV reclosing type cannot hold, so it will stay open. So that's where you will use a non-reclosing type. It is also mainly used if you have a high viscosity liquid in your tanks, probably, and you have a high potential of plugging. So that's where you won't use your reclosing type, because it just won't close. So when do you use a reclosing type safety device? It is normally into application where you need to return back to your normal operating pressure. So that's where you use, means it's open, you remove the excess pressure, you close back, and then it will back to the set pressure, normal operating pressure. So the set pressure is insensitive to the temperature. This is where you have I could say viscosity issues, because it's mostly because of temperature fluctuations. That's where some of the medium will turn into solid or probably viscous. So you use a reclosing safety device also when it's not affected by fatigue. So meaning to say it can function correctly. So let's just look into the type of non-reclosing and reclosing safety devices. So the first one of the most common non-reclosing pressure relief device, number one, as you can see in the photo, number one is rupture disc. So they will in the industry we will have three types of rupture disc used, which number one is forward acting, tension loaded, reverse acting, compression loaded, and also graphite shear loaded. So we will also have pin devices, as you can see on the right. For this one, the photo above, for pin device, you will see that they have a pin on top. So this is only one-time use, but you will have flange inlet and outlet. It looks like a safety relief valve, but it's not. So meaning to say, once the pressure exceeds the pin will break. Boom, as you can see on the photo on the side. So once the pin break, it will totally release whatever it is that is in the tank to the atmosphere or into a tank, other tank. So these are the non-reclosing type, means it's one-time use. So what is actually a rupture disc? Rupture disc is actually a device that contains a disc which ruptures when a static differential pressure between the upstream and downstream side of the disc reaches a predetermined value. So when it reaches a certain set point, it will break and it will just release, it won't close back. If you were to look at pin actuated device, it is actually the same, where it was actuated by a static differential of an inlet pressure designed to function by a buckling or a pin. What we call as a stem here, that is actually the pin. So it will break when it reaches a certain pressure. So it is basically held by a piston or a plug. The bottom part of the pin is held by a piston or a plug. Upon buckling or breaking the pin, the piston ring instantaneously moves in full open position. This actually makes all the item that you are relieving moves up and it won't get closed. So these are non-reclosing types. Moving on to reclosing types of a relief device. As you may say, this is what we are main topic, which is on the PRV safety valves. So the reclosing type of pressure relief devices are known there are three most common types, which is number one, spring loaded. As you can see on the photo on the left, there is a spring on top. This one. So that is a spring loaded pressure relief device, and you can see in the middle, that one is a pilot operated relief device, and all the end to the right, the white color one, that is actually a power actuated pressure relief device, also called a control safety pressure relief system. So it is operated by a motor. So spring loaded, as I said earlier, is held close by a spring. Pilot operated is a device where you will have the disc is enclosed by a system pressure, and the holding pressure is controlled by a pilot valve. So it's actually a combination of a spring loaded relief valve and also a pilot one. So you have a big dome over here, and you have a small spring, as you may see up there. So it is controlled by a pilot spring. They call it a pilot relief device. So the last one is a power actuated relief device. So these are devices which are actuated by an externally powered control device. So its motorized function is more advanced. So moving on. Alright, so normal common things that people will ask. I get many of these questions also. Sharin, what is the difference between a relief device, safety relief device, and a safety valve? Because some people may term it as PSV, some people may term it as PRV. So what are the difference? So let's just look at it. So relief valve are actually pressure relief valve. Is categorized by gradual opening and generally proportional to an increase in pressure. Meaning to say, your pressure increase, the valve will open proportionally. So you will have a graph like that. So it will open proportionally according to the pressure increase. Every increment will rise, will make the piston to rise. So it is normally used in incompressible fluids. So this is one of the main point that I would suggest. For relief valve, it will use in incompressible fluids. Where else, if you were to look at safety relief valves, these are pressure relief devices which are characterized by rapid opening or by gradual opening that is generally proportional to the increase in pressure. Means this one you will have a slightly straight graph. So because it's a function of safety, you need to relieve fast, so it will have a straight. Like just now, relief valve, it will have a curve. So it can be used in compressible and incompressible fluid. These are most likely to be the same. But when you heard about safety, it will open faster. But it will still reclose back. When it relieves the pressure, it will close back. Same for every safety relief valve, pressure relief valve, or relief valve is the same. Moving on into safety valve. Safety valve is a pressure relief valve that is characterized by rapid opening and normally used to relieve compressible fluid. This is mostly used in steam services. So when it reaches, it will straight open. So that is the safety valve. So remember, relief valve is normally used for incompressible fluid. It is proportional. Where else, if you were to look at safety relief valve, can be used for compressible or incompressible fluid. But here you will have slightly higher gradual opening of the stem piston, and finally for the safety valve, you will have a rapid opening of the stem, the piston. So it is normally used for compressible fluids. So what are the other terms and ideology that you will have looking into a relief valve? You will have mainly these four below terms that people use: reduced bore, full nozzle, and semi-nozzle. So reduced bore and full bore. So as you may see in the photo on the bottom, there is reduced bore, and the next one is full bore. As you can see, reduced bore at the inlet is sharpened, so it shows that it is reduced. The pressure will actually enters into a reduced area. So that's why it's called as a reduced bore. For full bore, as you can see in the second photo, it's straight, so it's full. If it's a full nozzle design, you will have a full nozzle until out. If it's a semi-nozzle, it will use a small half. as you can see in the photo below. These are most of the terms that people will use. Same like a ball valve, you have a reduced bore, full bore, but yeah, in ball valve you don't have a nozzle. So this is some of the things to look at in pressure safety valve. So these are the terms, basic terms that people will use. I think I'll skip this. So one of the other terms that we have is basically these terms. When you talk about the relief valve, you will have these 4 pressure terms. So let's just look at the first one, set pressure. Set pressure is the value of increasing inlet static pressure, means increasing pressure at your inlet, which the pressure relief device relieve one of the operational characteristics as defined as opening pressure, popping pressure, start to leak pressure, burst pressure or breaking pressure. Means set pressure is the point where it's just started to open, means it started to lift your piston up. So CDTP, cold differential test pressure, is also the inlet static pressure. You see, in the set pressure it started to gradually increase, but CDTP is the point where it stays static. It's a static point, only one value, which a pressure relief valve is adjusted to open on the test stand. So this test pressure includes correction for services condition of superimposed back pressure or temperature. Meaning to say, when your valve is designed, let's say at 10 bar, so some of the plant operators say let's increase it to 11 bar. So when you adjust that, you are adjusting the CDTP. So the set pressure remains at 10 bar, probably you want to adjust it to 11 bar. This is the CDTP value. If it's not adjusted, it's the same as set point. So next, moving on, what is the overpressure? Overpressure is a pressure increase over the set pressure of a relief valve, usually expressed as a percentage of set pressure. So overpressure, when let's say it says at 10 bar, it increased to 15 bar, so you have 5 bar overpressure. A blowdown pressure, on the other hand, is actually the value of decreasing inlet static pressure at which no further discharge is detected at the outlet pressure of a pressure relief valve after the valve has been subjected to a pressure equal or above to the popping pressure. So let's say your valve is set at 10 bar. So when you open, maximum fully open is open maximum full at 15 bar. So the 5 bar is actually the blowdown. How much pressure that you are blowing out. It may be less than 5 bar, or it can be 5 bar also. So that is the these are all the terms and definition used for the safety valve, normally for the pressure. So as you can see here is some of the conditions on how the pressure relief valve function. So let's just say the closing is at 90% of your set pressure. So let's say we put it at 5 bar, that is the closing value. Your set pressure is set as per just now is 10 bar, and the maximum relieving pressure at 15. Let's just say, yeah. So as you can see on your left is the lift, means the percentage of your disc movement. As you can see on your bottom is actually the pressure. Okay, moving on from point A to point B, as you can see, as it goes up, so meaning to say your pressure start to lift, but the highest point of the straight line from bottom to the top, this is actually somewhat around 50%. So you will lift and then you will still started to relieve. So when it started to relieve, the pressure still escalates more, because sometimes when you open you will have other contaminant coming in. So some of the common things that will come in is actually your oxygen, so you will make the the pressure spikes more. So that's why when the straight point goes to your point B, you will see it will rise, the pressure will rise more. So it is actually relieving. So that's where, as you can see at the bottom point, maximum relieving pressure, that is actually your I could say the maximum pressure that is relieved, which is 15 bar, let's say. So at point B, if you were to look on your left, is 100% open. So once you have relieved your maximum pressure, it will actually return back. So your pressure will start to decrease. It will move on your left, then it will decrease even more, then it will go down. So meaning to say from the set pressure, let's say 10 bar, when it goes lower, it will go down to the blowdown pressure, which is the normal operating pressure, probably around 5 bar. So these are how it goes and moves on a valve. moving on. So overpressure, if you were to look in different standards, usually in ASME 7, it's 10% overpressure. We will size every safety valve to 10% overpressure to actually support it. So if it's at 10 bar, it will be 10%, it's 11 bar. So these are some of the other. If you were to look at ASME 1, PG is 3%, EN, ISO standard is also 10% at 0.1 bar. So these are the different standards used. So it depends on which standards that you are using. So it can be actually, you have to follow these rules. So let's just move on. Moving on to spring-loaded safety valve. So as you can see, spring-loaded, you have a spring and you have a stem. The spring is in yellow color and you have your disc, which is probably in the blue color if you were to see. Somewhere over here, let's see. You can't see my mouse. Somewhere over here. There you go. So the operation of a spring-loaded pressure relief valve is based on force balance. So when the valve is closed during normal operation, the system or vessel pressure acting against the disc, your disc of this surface is resisted by the spring force. So your spring force is here, which is what? Pressing the disc, and you have a force bottom, which is actually balanced. That's why it's in closed position. So higher the pressure, the lower the seating force. When the system pressure approaches the set pressure, the seating force is null and the disc started to lift. So when you have more pressure from the bottom, you will actually push the spring up. This is all basic principle. So there are two types of spring-loaded designs that are widely used in the industry. So the first one is a conventional type. So a conventional pressure relief valve is a self-actuated spring-loaded pressure relief valve, which is designed to open at the predetermined pressure and protect vessel from excess pressure of removing or relieving fluid. So this is the conventional type, old school. So you have just a spring, you have a disc, and it will set at what pressure it will open. This is a very old design. So what are the advantages of a conventional safety valve is that it's most reliable in property size, it's cheap, widely used. It's also versatile and it can be used in many areas of service. So what are the disadvantages? The disadvantage of a conventional type is basically your relieving pressure is affected highly on the back pressure. So this is, you could say, if you have a higher back pressure, you can't use a conventional anymore. For example, your set pressure is at 10, you have a back pressure of 15, you can't use. So these are some of the cases to look at. So the suspectable of chatter buildup of back pressure is too high. So this is a very old design, probably in the early 1970s, 1960s. These are the widely used conventional type. But it's for normal operation, for not very high pressure, set pressure opening, it can be used. And it's very cheap. So second type, as you can see, is the balance type. If you were to look at this photo, so they have actually this thing over here. If you were to look before, see, you don't have anything on the wall surface. So this is your disc. So if you were to look here, there you have this particular balance bellows. They call it bellows. So a balanced pressure relief valve is a spring-loaded. It's the same, but it incorporated a bellow or other means of balancing the valve. So like I said earlier, spring-loaded is very highly dependent on the back pressure that is most effective, that will affect its performance. So over the years, people design it with a balance. If you have not that high back pressure, for example, you have around 3 bar back pressure, how do you actually remove the back pressure? Is basically by using a bellows. I will explain this more later. After this, you will have a look why. So the advantage of balanced bellow is it's not affected by back pressure that much. It can handle a higher build-up pressure and it protects from corrosion. This is the main point actually, it protects from corrosion. Because as you can see, the old design, the fluid, if you have a corrosive fluid flowing in your line, it will actually go up here, up till your spring, and it will corrode your spring over time. So if you have a corrosive medium or all those highly acidic stuff, you don't want to actually use a conventional type. So balance bellows will protect this one, so the fluid will not be in contact with your spring. It will close up here, so it will mostly move here and then it will goes out on your right. So everything have an advantage or disadvantage. What are the disadvantages is that the bellow itself, being a protection layer to back pressure and also the corrosive medium, it will get hurt also. So over time it is suspected to fatigue or rupture. Usually it's metal material, so it is suspected. So moving on, when you have these kind of things, you will actually relieve more of the flammable or toxic to the atmosphere because it's not contacted with the spring. So previously it will go through your spring, so your spring is holding, it's still in closed area. Now it straight goes out. If you didn't have I could say a container, you will probably just release to the atmosphere, which will cause many environmental problems in the future. So balanced pressure reliever to be used mostly when you have a build-up back pressure which is too high. Normally, balance valve applied where a total back pressure does not exceed 50%. Like I said, if you have a 15 bar, maximum you can go is 22 bar back pressure. But what if you have a 30 bar, means double? You are set to open at 15 bar, you have 30 bar back pressure, you can't use it anymore. So that goes to the second one that we have, a pilot operated type. When you have too high of a back pressure in your plant, you will use a pilot operated type. We'll look on to that later on. So this is the one that I say, the basic design. So this is balanced with a piston seal. So as you can see, it is not connected to your spring. Whatever that's relief here, it will go also out to your right. Maximum will go till up here. So these are the particular design of a balance valve. So apart from the set pressure, CDTP, set pressure and CDTP, you have here superimposed back pressure. So there are 4 types of back pressure. Just now we are talking about set pressure, the one that's moved the the pistons up. So this is more in your system. Now we have something more, which is on the back pressure. How do you actually quantify different types of back pressure? So the first one we have is the superimposed back pressure. So for this one, it is actually a static pressure at the outlet. So means constant pressure at your outlet. It is a result of a pressure in the discharge from other source. So this is your superimposed. But then if you have a variable back pressure, a superimposed back pressure will vary over time lah. If you have a static, it's called superimposed. If you have a variable fluctuation of pressure at your outside back pressure, that is called a variable back pressure. As you can see on the photo over here, this is what they call as a constant superimposed back pressure, whereas here, see, it changes over time. The color gets light. So I don't know what they write, but this may be quantifiable. So the build-up pressure is this is another thing whereby it's a pressure existing at the outlet of a pressure relief valve caused by flow through that particular device into a discharge system. If you have probably a tank over here, so this is what you call it as a build-up. So because you will have something over here which is enclosed in a tank, then that tank have a pressure. Probably when the liquid levels rise, the pressure also can go high. So this is what you call it as a build-up. Over time it gets built up because there is a liquid which is almost filling the tank over time. A total back pressure is basically the sum of all of these pressure that you have in your system. So this is probably the main what is the different definitions that people use of a back pressure in a relief device. Alright, moving on. So regardless of whether the valve is vented directly to atmosphere or the discharge is piped into a collection system, the back pressure may affect the operation of every valve. So whatever it is, you must make sure that your back pressure is properly sized. Especially if you want to use a conventional type, this is the number one thing that you really need to have. It's good to use a slightly higher assumption of a higher back pressure when you size, so that it can actually design to back pressure, so that you could have no worries over time. So these are some of the things that you will need to have a look. Alright, so moving on, this is what I said earlier. As you can see in this photo, this is a normal what they say, back pressure. Okay, this is on a conventional design where you have a force over here, which is the pressure over here, which is acted by the force over the area. So this is when you have no bellows. When you have a back pressure, you can see here the PB, this one is all over your sitting area. So this causes the force F plus PB is higher than your set pressure at down. So that's why if you don't size your back pressure correctly, this thing is not going to open at your predetermined set pressure. So it won't function well. So when you have I could say emergency situation, this won't solve. So you better size it correctly. Okay, looking into the second factor where you have a bellows over here, this is on standard condition where you have no back pressure. As you can see in this photo, it's directly proportional. So your F is equals to your P times your A. This is directly proportional. But if you have a back pressure, like I said earlier, see, it only touches the edge of the valve, the area, sorry, touches the edge of the area. So that's why you will have a much lower pressure, back pressure acting. So that's why it can still be proportional. So we neglect because it's very small effect. So this is why we use bellows design. So rule of thumb, it can be sized up to 50% back pressure. It can still hold. More than that, you need to use a different type, which is what I'm going to talk later on, which is on the pilot type. So for, I could say, conventional type, these are the basic accessories that will normally come. We'll have a test gauge, soft seal, flushing nozzle limit. So this is all, you will learn it later on. So this is the test gauge. This thing used is to lock. When you have a plant, you are actually setting when you have a shutdown, it will fluctuate, so you lock, let it go at certain pressure. When the plant reaches the optimum operating condition, that's when you open your lock. So this is the function of a test gauge, and many more. So we are running a little bit out of time, gentlemen, so I will move on. So let's just look at the second type of relief valve. So this is the pilot type. So a pilot operated relief valve is actually a pressure relief valve, which is a major relieving device or valve combined with control by a self-actuated auxiliary pressure relief valve. So this is what I say, you have a pilot valve controlling your main valve. So the pilot valve is something like a conventional valve. So there are two types of pilot operated relief device. The first one is pop action, meaning to say it is used in fully open or fully closed condition. So these are when you need it to relieve very fast. I mean, because conventional type you have a spring, and this one you set, it will straight open, boom, pop. So these are when you have some conditions requiring a very fast action of pop action, fast action of relieving. So you will opt for this one. And also the second type is the modulating action. So the action is characterized by modulating opening and closing of the disc. So you will use this pilot operated type mainly in two design when you have a very high back pressure. Let's say your set pressure is 15, you have a 30 bar back pressure, double of whatever that you are using. So that's where you need to use more than 30 bar or whatsoever, you need to use a pilot type. And also the second one, when you have you need it to actually function fast, very fast moving, because this is fast acting. So you will use a pilot operated. For conventional type, it is proportional. So it's not as effective because it is a very old design. So this is the new one, which is widely used. So like I said earlier, this is the sketch drawing. As you can see, the pilot, what does the pilot will do? It is that it will sense the process pressure through the sensing line, which is down here. This is the sensing line. So this pressure will rise up. So you will set your pressure here. So this set of pressure will actually move this dome chamber up. So when this thing is open, so this thing also will rise. So this is the main valve, your valve body, and you will have a dome. So the pressure into the chamber is actually determined by the closing thrust. So this is the main pilot, which pilots the main valve. So that's why it's called pilot operated valve. So moving on, this is basically some of the design and so on. So let's just look at some of the fundamentals. So in normal operating condition, the dome chamber is connected to the nozzle. Like I said earlier, this is your dome chamber, is connected to your nozzle. Via the nozzle to your pilot. So the pressure in the dome is the same as that in the valve. Means your pressure at your dome here is the same as in your valve. So same as the valve inlet, and since the area of the dome is larger than the area of this nozzle, a force that keeps the valve closed, the valve starts to open. Usually you will design it as 70% of your nozzle. So when it reaches 70%, it will open. So it will also cause your dome to open. So when your force at your dome is more than your force at your nozzle, means this force is higher than this one, so the valve will close. So when your force of your dome reduce, meaning to say you have a higher build-up over here, obviously your Fn will be more than your Fd. So that is when the valve will start to open, because a higher pressure bottom here, it will also escalate to a higher pressure in your pilot. So that will cause your pilot to move up. So when your pilot is move up with a higher pressure force here, so it will actually open. So this fast acting, small surface area, high pressure and so on, this will actually be precise. When you have a precise opening, you will use a pilot operated type. So let's just move on. So this is one of our ASD's I could say famous design. This is for pop action. You use this model. So there are not many manufacturers that have I could say this pop action. There are not many manufacturers that have a pilot operated relief valve. So this is as you can see an example. So this is when you can see the fluid flows in. So when your pressure started to rise, you see when it goes to red, it will start to relieve. So that's why all this blue color will goes up, it will relieve. And then this piston dome will rise. When it goes down, it will close back. So that is typically how it moves, right? So the second one, the pressure modulating pilot. So this is the other design that ASD have. So its function more or less the same, but this is more on the modulating type. So it will release and it will close back, which is even faster. The design is like that. So the lift of the main valve piston, unlike conventional or balanced spring loaded, is not affected by the back pressure at all. This allows for even higher pressure of relief discharge manifold. So you can go up to 100 bar here, as you can see. So this is your opening. So it is not proportional. So you can see it open very fast. Then it will start to lower down a bit. So this is the back pressure. So thank you everyone. I think that's the end for today. A bit boring I could say, because this is more of a technical talk. So if you guys have anything to ask me or whatsoever, any questions, please feel free to drop me an email, Shahrin, SHAHRIN @turcomp.com, or you can just call Turcomp and look for me. My name is Muhammad Shahrin. So I am the person in charge for PSV and PRV. Even students, if you have any questions on a deeper understanding for valve, safety relief valve you are doing for your final year projects, you may consult me. I'm here to help. Alright, thank you very much everyone. Have a great day. Bye.